Today I want to present how KWin went XCB. Over the last year, or actually over the last 2 years, we went from being an XLib only code base to a mostly XCB only code base. A little bit about myself. My name is Martin Gräßlin. I'm currently the KWin maintainer. When I'm online on IRC, which I'm recently not that often, I'm found under the name M. Gräßlin, and I'm working for Blue Systems with a focus on KWin, and with the last year focus on the XCB and the Qt5 port, and now with a focus on the Wayland port. A little bit about KWin. KWin is the window manager and OpenGL compositor for the Plasma workspaces. It's also used by other desktop environments, so it's very commonly used in the LXDE, LXQt world. I've also seen that lots of XFCE users are actually using KWin, which is kind of surprising to me. We can be cloned on KDE's Git infrastructure. KWin had been around for a rather long time. It's since 1999 in development, got introduced in KDE 2.0 based on code from KDE 1, which is from 1996. So we have quite some legacy code, and we are also a rather large window manager with, according to Olo.net, 127,000 lines of code. So porting that to XCB was not the main straightforward thing to do because of the number of legacy code. So let's start by looking at why we did all that. And the reason is Qt5, which basically told us in their porting note that they don't have X events anymore, but pass us XCB generic event T, and so your application has to be ported to XCB. Obviously, that only matters to the event handling. But in addition, they broke rather a few assumptions on our world. So first of all, in the good Qt 4 days, everything was happy. If we are on Qt in the Linux world, it's X11. Now, with Qt 5, they introduced the Qt platform abstraction. So it could be X11, it could be also Wayland, it could be Android, it could be Mir, it could be whatever. So that assumption is gone. And then there were a few more assumptions which we had. So a Q widget is always an X window. So we use Q widget to create windows. That's gone. Q pixmap, X pixmap, gone. It doesn't reference it at all anymore. It was already rather broken in Qt 4.8 times, but in Qt 5 it's just gone. We don't get native cursors anymore, and our Q region is no longer an X region. So we used all of that, and that needed ported. I gave a talk about that at last year Academy called We Are the 1%, because Qt provides the guarantee that 99% of the code will just work. We were the 1%. So the state before the porting, so our XLib handling code was in multiple modules. We had inside KWin 1,500 lines of a huge switch statement for the event handling. In addition, we had in the KDE libraries 4,500 lines of code doing all the netWM handling. During startup, KWin performs 1 xget window attributes per window, which is already present, and an additional 15 xget window properties in the KDE Labs code. And for each managed client, we do about 27 xget window properties calls in the KDE Labs code. So that is the amount which we can optimize by going to XCB. What I also found out recently is that we read several properties multiple times. Well, legacy code base, things get added. And what's really nice for the porting was we had 0% test coverage for all of that. So we had to go port the huge switch statement and the Qt5 port at the same time, hoping that nothing breaks, because no tests. And we couldn't just port either to Qt 5 or just to XCB. We had to do it at the same time, because in Qt 4 we got X events, and in Qt 5 we get XCB events. So there was no chance to do a smooth transition. We had to do it at one time, which was challenging. So I tried to do it before with an approach of doing it in a more modular way, to have it a shared code base, but I gave up on that and went for the let's port it and see what breaks. Given the number of configuring options we have in KWin, that's also rather challenging. But we succeeded. So now I want to present a few of the obstacles during the porting. The first one, what I should say is that is all about the state how it was a year ago. So the doxing documentation on the XCB websites were pretty bad, but that improved a lot. So I wanted to get an example for this presentation, and I noted, whoa, it's properly documented nowadays. But it doesn't hold for the extensions. So that is a typical documentation how it was like last year. All we get is, it delivers a request to the X server. Yes, thank you. Every XCB request is doing that. And also, if you want to get the documentation, it's rather difficult. Has ever of you ever tried to Google them? So most oftenly, you have, if the name is too generic, like xrender, you can forget it. Everything is xrender. Sometimes you get to the Wikipedia pages, so that can help, but overall it's very difficult. Also, the normal X documentation, you cannot find it through Google. It will give you an outdated one. It won't link you to the latest one. And for this presentation, I tried to go through the steps. So you go to X.Org, then you click on X11 or 77, then you get to some releases page, and then you go to the documentation. And there you have it all. So not the most trivial thing, especially if you click on documentation on X.Org, you won't get there. For a few extensions, there are PDFs. For some, they are not. For example, all these extensions, which kind of matter to me because I had to use them, they are only available in a text file, which is kind of okay. And for some, I didn't find them at all. All I got was the XLib one, which doesn't really help if you want to do the XCB porting. It kind of helps because you can guess what the XCB code will be looking like, but it was not the easiest part. So my suggestion is also to get something like an annotated X protocol. So the X protocol still has lots and lots of stuff in it, which nobody should use, like polyplane, polyline. Nobody wants anybody to use it. But the things which people should use are not mentioned at all. So it would be really good to tell people to use either the shared memory extension or the render extension to do rendering and not anything of that. Also, input handling is not linked to what one should use nowadays. So that is something I would really suggest to do, to just go through the protocol, deprecate the stuff which should not be used, and add links to what should be used. Good. The next one will be XCB ICCCM. That is, was a rather interesting experience for me because the repository got split at some time. It used to be in XCB util, and now it's in util WM. I don't know when the split happened, but apparently not all distributions are providing it, and they provide the one or the other. So that would not be a large problem, but the API changed slightly. So it's not a huge change, but it just means that we have problems compiling if we want to use it. For example, our CI system, which is running an older OpenSUSE, doesn't provide it, which is kind of bad if the CI system breaks. And what's the problem for us is that the KDE teams and the distributions are normally pretty quick with providing the latest stuff for the KDE things, but not for the underlying stack.
That split happened in
that's the world we have to live with, unfortunately. Yeah, so X is considered something like a very stable thing of the system, and not all distributions update it, while KDE might get updated. And some distributions want to provide a new KDE for an old distribution, and we have users on old systems, so it basically means we cannot use it. So we wanted to use the defines. And so now we have something in our configure script to test whether the package is found, and if it's not found, then we just define it ourselves. It's not elegant, but yeah, what else should we do? But for the functions, we just don't use it. We are basically duplicating the code, because we cannot use the old, we cannot use the new one. Kind of a sad situation. Similarly, a nice problem we had with util, what was it? Render util. That's a part of the header. Does anyone see the problem if you try to use that with C++? It's having two problems. Yes, the external declaration is missing. And we have here this variable called template. So I succeeded with the extern C++, but I completely failed with the template when the compiler told me that you are not allowed to call a variable template, which makes sense in C++. So that's fixed nowadays, but as I just showed, we cannot use it because distributions won't have that fix. I found a workaround in Qt which looks like that. So apparently you can redefine template, which I didn't know. If I would have known, I would probably have went for the same approach. Good. Then the sync extension was very interesting. So that is the commit message which fixed sync. So that was a very, very difficult experience. So I ported the sync code, like everything in the huge, I port everything. And afterwards, I was not able to resize window anymore because the sync thing was broken. And I tried to figure out, and I looked at my code, and I searched the internet, I searched for examples, anybody using the sync extension. And I didn't find any code for the XCB sync site. And at some point I found the mailing list discussion about that it's broken, which explained a lot. But at that point I noticed, whoa, we are doing something nobody else has done. Apparently nobody used the sync extension of XCB for quite some time. And if you look at it, there are not many window managers which use XCB. To my knowledge, it's only Awesome and i3. Those are tiling window managers and probably don't need the sync extension. So our solution for the time being is we reverted that part back to XLib. And it will probably stay like that for quite some time because the fix is only in 1.10 and distributions will need time till we can use 1.10. We recently introduced 1.10 by accident and the CI system immediately screamed at us and OpenSUSE screamed at us the next day. So we fixed that part as well. Then XCB porting, that was also quite nice. So that is example code from KWin. So we try to find windows based on the XAny event, the window. We do that for various things and then pass it through the event filter of the window. So we just test, is the window in the event the actual window or the decoration or the wrapper window or, well, whatever, then pass it through the window event filter. Now, the window is documented very interesting. The window member is set to the window that is most useful to toolkit dispatchers. So, and that is for all events. So what is it in the XCB world? That's quite challenging. So this code is actually handling all events. And some events have multiple windows. Some of them are called event window. But is the event window the most useful to the toolkit dispatchers? Difficult to say. So today it looks like we have introduced a find window event, find window method, which gives us back then the window, and we change it to that. So the code still looks very, very similar, but we also have this wonderful function which gives us for every event, which is the event window as we expected. Maybe we still have something wrong. I don't remember exactly how I did it. Probably I looked at the XLib code for each of the events, what is actually mapped to the window of any event. So that was not the nicest experience. And yeah, unit testing. Obviously, if we would have had tests, that would have helped a lot because it would have made everything much easier. But unfortunately, legacy code base, older than the concept of unit testing, is not what we had. And I tried to get more unit tests into all of that, but it's difficult. So what we found out is that some of our unit tests need a window manager and some need to pretend to be the window manager. In our CI system, XFVB is, on the other hand, run for the complete session. And if we have multiple window managers on that XVFB, it will break terribly. Then we have the problem that our CI system cannot run KWin itself because of dependency change. So the window tests have to be in the KWindow system framework, and KWin depends on KWindow system. So if the framework would have to bring up KWin, it would have a circular dependency. So our CI system is currently using OpenBox, which we know use kind of as the reference window manager we test KWin against. And recently I introduced a test which can crash OpenBox, which is then also problematic for the CI system. And it also means that any KDE-specific features against the window manager, if we have our own extensions, that we cannot test them. And what turns out to be a real problem is that all our developers test against KWin and then commit the test, and that fails on the CI system. One of the biggest challenges we overall have is that XFVB has a really bad XRender implementation. It only does 1.1, and that's not anything useful to run tests again. And mocking XCB is not a real solution, and I don't like even thinking about it because I don't want to know whether our code is correct against the specification, but that our code is correct against the X server everybody runs. So I'm rather bug-to-bug compatible than compatible to the extension, to the specification. And what we also noticed that if we have unit tests interacting with the window manager, they can become very fragile. So we have tests now which check whether OpenBox is running, then we skip it, and other tests which need KWin, and then they behave differently, the window manager, so the test code has to decide which window manager and test differently depending on the window manager, which is not the best way to test things. So the next thing after all these obstacles, the obstacles does not even include the problems we had with Qt5's XCB backend, which was pretty new and not yet ready to develop a window manager on. So there was rather more in it, and sometimes I felt like running with the head against the door, and once I break through, I noticed that there's a steel door next to it. So yeah, it was kind of tough. So the C++ side. So that is now a typical code as you could find it in KWin. We need to get the geometry, we need to get the reply, we need to check, and from the geometry we create a QREC and then do something and return early and free. And obviously that was leak, which would be bad. So yeah, the problem here is the free. For a C++ developer, that's a not so good thingy, because free exceeds the language barrier. In C++, you don't use free, you use delete. So at that point, you not only see that you use a C library, but you are introducing C code into your C++ application, which is dangerous because you have sometimes developers who might not notice that they are interacting with a C library and might introduce a delete by accident and the code would crash. And the next thing is that C++ is a memory managed language, which many don't know, but well, it depends how you write the code. So if you write the code in a way that you don't need to use delete, then it's memory managed. And that's what we have here. We use the QScope pointer and to free the variable once we don't longer need it. So that is the same code using a scoped C pointer, and that will not leak because the scoped C pointer will clean up after us no matter where we exit the function. What I should say, C++ is memory managed, but it's not a garbage collector. That's something one has to differentiate from. So Java uses as memory managed and garbage collector, but C++ is just memory managed. If you use C++ correctly, you can use C++ in a way that it's not memory managed, obviously. So, but there are obviously more ways to leak an XCB. So you could, for example, return before you get the reply, and so you should use a discard. That's something we hit pretty early because we need to read multiple properties and then decide on whether we continue to look at the next ones, and then we need to discard. So we didn't like that as well because it again introduced the possibility to leak. And we introduced something which looked like this. We have a wrapper class for the actual XCB request. We only process now the window we operate on, so we don't have the connection anymore. And as soon as we need to get the reply, it will be fetched. Otherwise, if we return early, it will just be discarded. So that's what the deconstructor then takes care in our wrapper. So with, before C++11, we were only able to do it for a very limited subset of commands. And now with C++11, we can do that for every XDB command. Oh, we have a static method called connection. So what it does is the constructor performs the XCB get geometry unchecked, and the reply is actually delayed till it's needed for the first time, and the deconstructor frees the reply if it got fetched, but discards it in case it's not fetched. In addition, we implement the error operator, so it behaves just like an XCB get geometry reply T if needed. And yeah, as I said, for us, the additional nice candy is that we don't need to pass in the connection anymore because, well, in KWin we only have one connection and it's always the same one, so that can be optimized away. And with the help of C++11, we were able to get that working for all requests because there are no variadic templates, and that allows us to define the request function in a very generic way. So we see here, this will map any XCB request of the type returning a cookie and having a certain number of arguments. And it doesn't matter if it's 0 to whatever it will just work for everything. That is just the definition of the types we will need in the whole thing. So for the concrete example for the geometry looks like that, where we then pass in the actual functions. So we see here we have the combination of the get method and the reply method. And that is then wrapped into an actual class, which is now what it provides. And we have for that a concrete implementation, which is again with variadic templates. And here we have now the concrete example how it looks like. So we have a class window geometry, which extends from the wrapper with the geometry data just shown and the arguments which need to go into the method. That's actually wrong. It should be XCB drawable T, but as it's the same underlying type, it doesn't matter. If it would be a different type, the compiler would yell at me. So it even has some arguments checking that you combine the correct methods with each other. And what it also has as a nice additional candy for the Qt users, we directly convert it to a key rect. So we have a method rect, and it just combines the various values, or if the reply failed for whatever reason, gives us an empty rect. So that's exactly what we want in most cases. And yeah, the advantage for us is that it works with all request-reply combinations. So we only need to specify it once, and we have the same code pattern for everything we need. We have the compile time checks for the argument specifications. We can ensure that it's no code duplication. We hide the XCB data types and requests. They can get a little bit long. And in C++, we have namespaces, so we don't need XCB underscore extension underscore something, something, something. We have namespaces for that. And it completely hides the async nature of XCB, which is something you not always want, but sometimes you want to have it sync. And when you want to have it sync, this will behave sync. If you want to have it async, it will behave async. And what's really good is that we now have all the requests under tests. So we wrote unit tests for that, and we know that when we add new tests, add new wrappers, they will work. And for our C++ lovers, we use camel case instead of underscore, so that's also making our code base a little bit more consistent.
Kind of funny considering how much effort we put to generate the underscore versions from the camel case protocol.
So actually, I think you did right there, because from the C perspective, that's what you want. So XLib was not really good in that, was just everything X something. But from the C++ side, it's kind of not exactly what we want. We are actually doing kind of the same for Wayland nowadays. So for Wayland, we also have our C++ wrapper, which then makes everything camel case again. Well, it mixes our code base. So everything's camel case in our code base. And having something which is underscore makes the code much more difficult to read, and from the aesthetic, it doesn't look that nice anymore. And I'm always a little bit concerned that we make our code base too difficult for new people to get into. So I rather have one consistent coding style. So yeah, one of the really nice things is how we handle properties. So if we want to get a property, we actually added some things like we can validate the type and the format. So if we say we want this and that property to be read, that it actually validates at compile time that it has the right format and the right type. We can cast it to the requested type. We can handle properties with an array value or one with just one value. And we get the format from the request type. So if we say we want something which has an uint32t, then it's obvious that it has to be format 32. Or if we want a string, then it's obvious that it has to be a format of 8. And what we also have is a very simplified reading for qbyte array. So if we have a string property, it will just convert into a qbyte array. So that's an example how we do it. We have the property wrapper. We pass in what we actually want. So that goes directly into the property request. And what we get back is an array of UN32T. And it's checked that it's really of format 32. It's checked that it's of type cardinal. So if that doesn't, if it doesn't apply, it will return a null pointer. And that here is an example for how it would be if it would be a single value. So this would be a conversion to a tuple. If the value is 0 on the property, it will return false. If it's a value of 1, it will return true. And that's how we read a string. So we just have a string property, and it will be completely sync in this case. It doesn't have to, but in this case, it's completely sync because it has an internal cast operator to qbyte array. And so if we want to, we can read a string property with just one line of code. And we also have a complete wrapper for a window. So that is an interesting code base because it will generate lots and lots of warnings with C++. So what with this code could generate warnings? Anybody an idea? So the problem is the warnings look like that. And that is because the geometry here are integer values, the QRect, and we pass it into unsigned integers. And according to C++11, that is a narrowing conversion and returns warnings. So at the point where we enabled C++11 for our code base, we got thousands of warnings like that because we had also in the XLib code base that all over the place. And yeah, we had to narrow it down, so we put that actually in methods. And the proper way is it has to look like that. It could also be a C-cast, and yeah. So, but the point is that's getting a little bit ugly if you have to do it at every point, and you have to remember it, otherwise you get warnings, which you don't want. And so we had to do something about it to not need that at every point. And we started to adding also wrappers for the window classes. And again, we use the resource acquisition as initialization. So basically, it means if we create a window, we also want to have it destroyed. And we don't want to remember to do that. So let's use the C++ method to do it. Like in this case, we here create a window with a certain geometry. It's input only. It has this mask and these values. And when it goes out of scope, it will be destroyed again. So that's what we normally want to do. And in this case, we also have implemented the casting operators so that it can be just like a normal XCB window T when we want to. And again, for us, it hides the XCB connection T. And from a C++ perspective, it also makes it easier to use because now we can just say window.map instead of XCB window map with the connection and the window. So it's more object-oriented if one wants to say it like that. And again, this allowed us to add unit tests to pretty much everything which uses Windows because we just had one place to test. It also allows us to manage foreign windows, which we don't want to destroy. That's mostly needed for, well, as a window manager, you get at some point a window from a different client. All of that is inline, so it doesn't add anything to the actual, so we don't have function lookup. That's what I wanted to say. And we offer a lot of convenient methods which are similar to what XLib provided. and which XCB is kind of missing, like lower arrays, which all go into configure requests, and move resize with the respective Qt wrapper. So now, actually, we have a lot of more wrappers around XCB, which I don't present. So we also have atom wrap and a few more things, but it's kind of the same approach for everything. So the current state, not everything is ported yet. As I mentioned during the presentation, the XLib extension doesn't work or didn't work. So that's still XLib. Also, everything related to Xcursor is still XLib. There is nowadays, I think, an XCB port for Xcursor, if I know correctly. But again, the distribution problem and the compositors are not ported at all. They are also completely XLib. In the KWin code base, we do not have ported the motive property handling because I'm scared of touching it and breaking it. They are a little bit strange and not documented. We have a few properties which are not yet ported. We still have a call to xget wm normal hints. If we would be able to use ICCCM, that would not be a problem. We could just use it. We still have one call to xget wm hints, which is basically ported but currently blocked by the feature freeze we just had for Frameworks 5.3 and Plasma 5.1. And we still use the with mode extension in XLib, and there's some key map interaction. So it's all doable. It just needs a little bit of time to do it. And yeah. The advantages we currently have through the porting is that we don't block anymore when reading the properties. And that are many properties, especially when managing the client. And we also moved more into NetWM, and NetWM is completely reading all properties in one go without blocking. In KWin itself, it's still that we kind of need to reorder code to make better use of it. And it's really good under test coverage nowadays, so that's now for the KWin system, and the NetWM implementation has a line coverage of about 80%. Compared to the 0% where we started, that's quite an improvement. So, and with that, I'm at the end of my talk and open to any questions.
Well, I'm super excited. One thing I was wondering was why are you using the unchecked variants of the requests?
Because in most cases, we just don't care about whether the request will fail or not.
But that means that the error goes into the event queue and you'll see it in your event loop.
Right. So mostly that didn't really matter to us. So we have the possibility to get from Qt the event, the errors. And if it's one of the one we know that we created them, we can just ignore them. Like if it's something compositing related, we can just ignore them. If it's damage related, we can just ignore it. It's only a problem for those which are in shared code. And actually, we don't have that many X errors appearing. So it's quite decent.
I don't actually understand your explanation. I'm sorry. So if you, for the requests that have a reply, where the simpler version of the function, the one with the shorter name, which just doesn't have unchecked in the name, that version will, when you go to wait for the reply, if an error arrived instead, and you didn't actually pass it a place to put the error when you wait for the reply, then XCB will just discard the error for you and you'll never have to think about it. Which seems like the simplest way to get the result that you seem to be asking for.
Then I expect that that was not properly documented, so that we didn't know about it. So my understanding of it was like, yeah, if you use the checked one, you also have to check for the error.
So that is true if it normally doesn't have a reply. So it's what we call a void request.
Yeah, but then you have to use the explicit checked variant.
That's what I'm saying. For those cases, it's a different story.
Okay.
But for the ones where you explicitly put unchecked into the name of the request, your life would probably be better if you just deleted the part that said unchecked.
Okay. So yeah, we can change it easily because it's just one file where we just have to exchange it. Thanks.
I have more questions for others.
Please correct me if I'm wrong, but I think it is currently impossible to migrate compositing to XCB because you cannot do direct rendering over XCB. Is that correct?
libgl doesn't have a counterpart.
But EGL also take the X display and not the connection.
EGL is not an option. Until NVIDIA ships it, EGL is not an option. Like until they have an EGL that has that works on desktop and does the right thing when you're under X11, that's not something that I can expect KWin to do. We've sort of resisted trying to do a XCB API for GLX because, among other things, it involves replicating all of the knowledge inside of the existing libgl about what to do with the difference between direct and indirect contexts. Libgl is not just a binding to the Windows system to the wire protocol. It's also this shunt aside to whatever the direct rendering interface happens to be. We could give you one, and it wouldn't work. Like it would work on against Maze's libgl. And then we would need to figure out how to get everybody else to ship the same one, or at least ship one that's functionally equivalent. You can't. I'm going to reveal a secret at this point, which is that the context tag and the context XID against X.Org are numerically identical, but otherwise there's really no way to get a graphics context XID out of GLX. It's just not there. So how are you supposed to pass that around? Because currently the XCB API doesn't know anything about context tags, and it would have to internally, and it would have to share the same lookup table as libgl does. Like as an implementation problem, that's why there's not a libgl. And so I recommend sucking it up and just using the XLib API for it.
I mean, don't have any problems with using XLib for the GLX and EGL backend. For me, that doesn't really matter. I'm kind of see there already Wayland on the horizon, so from the compositing experience, I don't really care whether it's XLib or XCB. I would be happy if I don't have to use XLib for anything in the window management part, because that means I don't have to first create an XLib connection and then the XCB connection from it, but otherwise I don't care.
So other bit for the property request part of the game, were you seriously not doing the thing Metacity's been doing for over a decade of using the XLib internal API to just throw all the requests out for get property and then eat them back asynchronously? Because that API can't ever go away. That's already how extension libraries work, and Metacity just includes xlib.int.h and runs with it. Were you not doing that?
I kind of didn't really get the question, sorry.
There's an internal API in XLib that is the asynchronous XLib has an asynchronous interface. It's ugly.
It's horrible, yes.
It's not something that you necessarily want to use, but the code has been there to do this in Metacity for well over a decade. You realize, oh, I've got to grab all the properties. And actually what Metacity does is it doesn't even bother to filter which properties it wants. It just, every time it gets a property notified that on a window it's interested in, it grabs them all, every single one that it might possibly be interested in. And the way it does it is it constructs however many requests that is, tosses them on the wire, and then get requests to pull them back off as they come back in. So you build them all up at once, you get all the replies at once, and you're not actually waiting for the reply. So it's effectively just the one round trip instead of millions.
Apparently we didn't do that.
Well, it's licensed under GPL v2+, so that would have been an option. I'm a little surprised. Like that was a pretty big performance win when Metacity did it.
Apparently we didn't do. So if it's GPL version 2 plus, it wouldn't work for us in the KWin system code. So maybe that was the reason why it was not integrated.
Sure. Yeah, it's
Yeah.
the API is
But no,
totally
I don't
writable.
care anymore. That's history.
It does seem like you went to a lot of effort to wrap this in C++ to avoid needing to know how to write C.
Yeah.
I'm going to not state an opinion on that mentality.
So I actually presented that because it's all header only. So if anybody is using C++, he is happy to take that code. But yeah, I can understand why C developers might not completely understand it.
Yeah, wrong set of trade-offs.
Have you done some speed comparison between the two versions?
No, but because it's very difficult, too much has changed on the stack. But one thing we noticed after a release of the 5.0 was that we got lots of praise for the speed. And we didn't really understand it because we hardly did performance improvements, optimizations. And I expect that it's the XVB port. So both in Qt and inside KDE.
Okay, that's it. Thank you.